How can we visualize linear motion? How can we compare the motion of different objects or the same object at different times? One way to do this is to use graphs, which are visual representation of data using lines, curves, or symbols. Graphs can help us understand the patterns and relationships between different quantities of motion, and in this lesson, we will learn how to draw and interpret graphs of linear motion using two common types: distance time graph and velocity time graphs. We will see how these graphs can show us the speed, direction, and acceleration of an object moving in a straight line. And by the end of this lesson, we will be able to define and calculate distance, displacement, speed, velocity, and acceleration for linear motion, draw and interpret distance time graph and velocity time graphs for linear motion. We will first start by talking about importance of graph. Then we see how we can interpret, draw the graphic representation of regular or uniform speed. Then we talk about acceleration. So what is the importance of graphs? Why we use graphs? To elaborate this, let me show you these two tables, and if I ask you to determine which city and at which month will have the highest temperature, it will take you a while to go through the numbers in the table and analyze them. But with the graph, it just takes you one look to know that city 2 at August month will be the highest temperature. So scientists, physicians, and mathematicians use relations like graphs in order to predict the relation between certain physical quantities, understand the practical results, and describe the physical phenomena in an easier way. So we use graphs to make it easy for us to study the physical quantity and the relation between each physical quantities, and to go easy and understand the data with more ease. Second, let's see how we draw the graphic representation of regular or uniform speed. So first, the relation distance time for a body moving with a uniform speed. We know that uniform speed means that the body covers equal distance at equal amount of time, so the relation will be represented by a straight line passing the origin point. So the relation distance time for a body moving with a uniform speed is represented by a straight line passing through the origin point, and that's because distance and time are directly proportional at constant speed. So because the distance is directly proportional to time when the object moves at constant speed. Second, the relation speed-time for a body moving with a uniform speed. Uniform speed again means that the object moving with the same speed. So the speed of the object don't change, and the relation would be represented by a straight line parallel to the x-axis or time axis. So the relation speed-time for a body moving with a uniform speed represented by a straight line parallel to the time axis x, and that's because when the body moves with a uniform speed, its speed remains constant, because the object's speed remains constant as time passes. So finally, the relation distance time for a body at rest. Body at rest meaning that he don't change position or don't cover distance. So the distance of the object will remain constant. So it will be represented by a straight line parallel to the time x. So the distance time graph for an object at rest represented by a straight line parallel to the time axis or x-axis. The relation distance time for an object move at a non-uniform speed will be represented by a curve passing by the origin point. Because the body moving with non-uniform speed, the speed will be changing with time. The opposite graph represents the motion of a body. Mention the kind of speed and give reason. So we know or we see that the graph is represented by a straight line passing through the origin point, so it must be a uniform speed. So the motion of the body is regular speed, and why? Because it's represented by a straight line moving by the origin point. Then calculate the speed of this body. To calculate the speed from the graph, we need to calculate the slope. So the slope for the distance time graph equal speed. And to calculate the slope, we get the difference between y-axis over the difference in x-axis. And the difference we refer to as this little triangle known as delta. So it will be delta y over delta x equal, we take two numbers, 20, and until it intersect with the line, and then we go to x, and then from y until it intersect, and then we go to x. So it will be 40 minus 20 over 2 minus 1 will equal 20 over 1 equal 20 meter per second. So the speed of this object is 20 meter per second. And again, to calculate the slope from the graph, to calculate the speed from the graph, we need to calculate the slope of the graph. Calculate the distance covered by this body after 3 and 10 seconds. So after 3 seconds, we take and then until it intersect with the line, and then we go what distance. So after 3 seconds, it will be 60 meter over 3 seconds equal 20 meter per second. And after 10 seconds, will be again 20 meter per second, because the object moves with a uniform speed, so the speed of this object will remain constant. From this table, represent the relation graphically. So we draw y-axis and the x-axis. Y-axis will be distance. X-axis will be time. So time 1, 2, 3, 4, and 5. 5, 10, 15, 20, 25, 1 with 5, 2 with 10, 3 with 15, 4 with 20, 5 with 25, and it will be a straight line passing through the origin point because the body moves with a uniform speed. So mention the kind of speed. Again, it will be uniform speed, giving reason because it's represented by straight line moving by the origin point. In the opposite graph, calculate the average speed of the hike during the trip. The average speed equal all distance over all time equal the all distance will be 50 meters in time 5, so it will equal 10 meters per second, which is the period in which the hike stops. Stops meaning that he don't change position, so the graph will be represented by a straight line parallel to the time axis, so it will be from P to C or PC. What are the periods during which the bike moves at a regular speed? Regular speed in the graph will be represented by a straight line passing through the origin point. It will be from A to B and from C to D. From A, B, and C, D. Finally, what is the period during which the regular speed of the bike is the greatest? So which period from A to B or from C to D the bike was going with a greater speed? So in order to mention, so in order to get in which period the bike speed was the greatest, we need to calculate the speed from A to B and the speed from C to D. So speed A B will equal distance over time. So distance is 20, time is 2, equal 10 meter per second. Speed CD again equal distance over time. The distance will be calculated from 20 to 50, so it will be 30, and time from 4 to 5, which would be 1, it will be 30 meter per second. So the bike from A to B was going with a speed 10 meter per second, and from C to D, the bike was going by a speed 30 meter per second. So the period from C to D, the bike was going with the highest speed. So what is acceleration? To understand, look here, you see that the car speed is changing with time, where after 1 second, the car speed was 3 meter per second. After 2 seconds, the car speed became 6 meter per second. And after 3 seconds, the car speed became 9 meter per second. So the car speed changing with time, and the physical quantity which describe the change in the car speed in 1 second called acceleration. So the acceleration, it's the change of an object's speed in 1 second in a specific direction, or it's the rate of a change of speed. And to calculate acceleration, we calculate by change in speed over time in which that change happened or occurred. And change mean difference, so to be the final speed minus initial speed over time. And change again refer to delta, which is this little triangle. So the acceleration calculated by the final speed minus initial speed over time, and the measuring unit of acceleration is meter per second square. And if the body moving at a regular speed, the acceleration will equal 0. If the body starts moving from rest, the initial speed will equal 0. And if the body was moving and stops, the final speed will equal 0. So if a bus moving in a straight line, its speed change from 8 meter per second to 20 meter per second within a period of 3 seconds, what is the amount of acceleration? So acceleration equal final speed minus initial speed over time. So acceleration will equal final speed 20 meter per second minus initial speed 8 meter per second. That change happened in a 3 seconds, so the time is 3 seconds, equal 20 minus 8, 12 over 3 equal 4 meter per second square. A car starts movement from rest and then speed increases to 60 meter per second through 5 seconds. And car B starts movement from rest and its speed reaches or increased to 80 meter per second through 10 seconds. Which of the two cars moving with a greater acceleration? So acceleration of car A equal final speed minus initial speed over time. So the acceleration of A will equal, the final speed is 60 meter per second. The initial speed, he tells us that the car starts moving from rest, and we said that when the car starts from rest, the initial speed will equal 0. That change happened in 5 seconds. So the acceleration equals 12 meter per second square. And acceleration of car B, again acceleration equal final speed minus initial speed over time. So the car B, the final speed of car B is 80 meter per second, And again, car B start moving from rest. So the initial speed will be 0. That change happened in 10 seconds, equal 8 meters per second square. So the acceleration of car A is 12 meters per second square, and the acceleration of car B is 8 meters per second square. So car A moving with greater acceleration. An object moves at an initial speed equal 7.5 meters per second. Calculate the amount of time at which the final speed of the object becomes 4 times its initial speed, knowing that the object moves at acceleration equal 10 meters per second square. So acceleration equal final speed minus initial speed over time. We need to calculate the time. So the final speed is 4 times the initial speed. So the final speed equal 4 multiply 7.5 equal 30 meters per second. So the acceleration equal 10. So we substitute A by 10. So 10 equal 30 minus 7.5 over time, which we need to calculate. So 30 minus 7.5 equals 22.5 equal 10t, or 10 multiply time. And to calculate the time, we need to divide by 10. So time equal 2.25 seconds. Notice here that again the car speed changing with time. So this car moves by acceleration, but if we calculate it, the acceleration at each second will be 20 meters per second square. In 1 second, 20 meters per second square, 40 over 2, 20 meters per second square, 60 over 3, 20 meters per second square, 80 by 4, 20 meters per second square. So this car change speed by equal amount in equal times. So we refer to this car it's moving by a uniform acceleration. So the acceleration by which an object moves in a straight line where the speed changes by equal values through equal period of time, known as uniform acceleration. So what is meant by a car moves at a uniform acceleration equal 5 meters per second square? Uniform acceleration means that the car change its speed by equal amount at equal amount of time. So we say that means that the car change its speed by equal amount, which is 5 meters per second each 1 second. So this means that the car moves in a straight line and its speed changes with 5 meters per second each 1 second. And the uniform acceleration has 2 types: positive acceleration and negative acceleration, or de-acceleration. So positive acceleration, it's an acceleration in which the speed increases by equal values through equal period of time. So as you see the speed of the car increases with time, and in this case the initial speed will be less than final speed. And because it's a positive, mean that the speed increase as increasing time or by increasing time. So the relation between speed and time will be direct relation and represented by straight line passing through the origin point. As you see, the car speed decrease. So we refer to this as decreasing or de-acceleration or negative acceleration, and the acceleration in which the speed decrease by equal values through equal period of time. And in this case, the initial speed will be greater than the final speed. And because the speed decrease by increasing time, so the relation between speed and time will be inverse relation and represented like this. As you see, the car speed doesn't change. So the speed of the car remains constant as time passes. So this object goes or moves by constant speed, and the constant speed have zero acceleration. So this movement is called zero acceleration, which when the object moves at a uniform speed. And the final speed will equal initial speed, and it would be represented by a straight line parallel to the time axis. So what is meant by an object moves at a positive acceleration equal to meter per second squared? Positive acceleration means that the car or the object speed increase with time. So we say that means that the object increase its speed by equal amount, which is 2 meters per second each 1 second. So this means that the object moves in a straight line and its speed increases by 2 meters per second each 1 second. What is meant by an object moves at a negative acceleration equal negative 2 meters per second squared? Negative here to refer or to tell us that this object deaccelerated or moving with a negative acceleration. Negative acceleration means that the car or the object speed is decreasing. So we say that means that the object go in a straight line in which his speed decreasing by equal amount, which is 2 meters per second each 1 second. So this means that the object moves in a straight line and its speed decreases by 2 meters per second each 1 second. An object moves from rest and its speed reaches 20 meters per second in 5 seconds. Calculate the acceleration of the moving object. Again, acceleration equal final speed minus initial speed over time. The final speed 20 meters per second minus the car moves from rest, so the initial speed will be 0 over 5 seconds equal 4 meters per second square. What is the type of acceleration? The car moves from rest, which was 0 meters per second and reaches 20 meters per second. So the speed of the car increase, so the type of acceleration is positive acceleration. A train moves at a uniform speed of 20 meters per second. When the driver uses the brakes, the train stops after 4 seconds. Calculate the acceleration and mention the type. Again, acceleration equal final speed minus initial speed over time equal the final speed the driver uses the brake and the train stops, mean that the final speed will be 0 minus initial speed 20 over 4 seconds equal minus 5 meters per second square. The minus here tells us that this type of acceleration is negative acceleration, and we refer to deceleration motion. An object moves in a straight line at a regular speed. If the time taken by an object to move from A to B is 4 seconds, then it moves at a uniform acceleration from B until it stops at C in 20 seconds. Calculate the following. Calculate the regular speed of the object to cover the distance from A to B. Speed equal distance over time. The distance is from A to B is 40 meters and he covered in 4 seconds. So the speed from A to B will equal 10 meters per second. Calculate the uniform acceleration. Again, acceleration equal final speed minus initial speed over time. The final speed, the object stops at C, so the speed equals 0 minus initial speed. Okay, the object was moving at a uniform speed 10 meters per second from A to B. So until the point B, the speed of the object was 10 meters per second. So the initial speed will be 10 over 20. So it will be half meter per second square. And negative because it's deceleration motion. A car moves at a speed of 60 meters per second. If the drivers use the brakes to decrease the speed by 3 meters per second, calculate the time after which the car stops. After using the brakes, the car speed was decreasing by an amount of 3 meters per second. So the acceleration is 3 meters per second. So the acceleration equal final speed minus initial speed over time. So the acceleration 3 equal final speed 0 minus initial speed 60 over time. So 3 time or 3t will equal minus 60. So we divide by 3 to calculate the time. So the time equal 20